Okay, these are our parent functions, and there are 12 of them. And this is how fast you should be able to recognize these functions and reproduce them and their names. The first function is a linear function. And it has these ordered pairs that make up the graph. What I'm drawing right now are lattice points. However, this line has an infinite number of points on it. I've just been able to show 21 given the grid that goes from -10 to +10 on both the x and y axis. The second is called an absolute value function. When you put a -10 in, you get a +10 out. And the same goes for any negative number that you put in. When you put in 0, you still get a 0 out. When you put a 1 in, you get a 1 out, a 2 out, a 3 out. You always get positive numbers out on your absolute value. Both number 1 and 2 require a straight edge because they are graphs that form straight lines. Number 2 also has 21 lattice points, but an infinite number of points that make up the actual graph. Number 3 is a quadratic function. When you put a -3 in, you get a 9 out. When you put a -2 in, you get a 4 out. When you put a -1 in, you get a 1 out. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. This forms a nice curve. It has an infinite number of points that make its graph. However, there are 7 lattice points that we can see. Number 4 is a square root function. We cannot put any negative values in for x here. We can put a 0. The square root of 0 is 0. When you put a 1 in, the square root of 1 is 1. The next input that I can get an integer out would be a 4. I put a 4 in, the square root of 4 is 2. And the next integer value that I can put in and get an integer value out would be a 9. Put a 9 in and we get a 3 out. This graph has an infinite number of points that make the graph, but 4 lattice points. Number 5 is a cubic function. Put a -2 in, you get -8 out, -1, -1, 0, 0, 1, 1, 2, 8. There are 5 lattice points, but an infinite number of points that make that graph. This next one is called a cube root. The cube root of -8 is -2. The cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. There are 5 lattice points on that grid with an infinite, on that graph with an infinite number of points on the actual curve. This next graph is called a semicircle because it starts off with a 9 right here. It's going to have a radius of 3. So when we put a -3 in, we get a 0 out. When we put a 0 in, we get a 3 out. When we put a 3 in, we get a 0 out. Next graph is called a rational function. It has a vertical asymptote and it has a horizontal asymptote on the axes. When I put a -2 in, I get -1/2. When I put -1 in, I get -1, and when I put -1/2 in, I get -2. When I put +1/2 in, I get a 2 out. When I put a +1 in, I get a 1 out, and when I put a 2 in, I get 1/2 out. There are 2 curves that make up this graph. And neither curve crosses the horizontal nor the vertical asymptote. Number 9 is called an exponential function. It has a horizontal asymptote at y equals 0. When you put a negative 1 in, you get 1/2 out. When you put a 0, a 1 in, when you put a 0 in, you get a 1 out. When you put a 1 in, you get a 2 out. 2 squared is 4, and 2 cubed is 8. And that's your exponential function. The logarithmic function is an inverse of the exponential. So it has a vertical asymptote, and all of the ordered pairs that are on the exponential, you reverse the inputs and outputs to get the points for its inverse. So 0, 1 becomes 1, 0, 1, 2 becomes 2, 1, 2, 4 becomes 4, 2, and 3, 8 becomes 8, 3. The natural exponential function has a horizontal asymptote, just like the exponential function does. It just has a different base, so it's going to look very, very similar to number 9, but it has a base of 2.718-ish raised to the x power. Let's make that look like the x that it's supposed to be there, raised to the x power. So when I put a negative 1 in, I'm going to get a fractional amount, a decimal amount that's less than 1. When I put a 0 in, anything raised to the 0 power is 1. When I put a 1 in, I get 2.7 out. When I put a 2 in, I get 7.3-ish out. Then I connect the points, and I enter and exit the grid always whenever the graph calls for it. And then the next one is called the natural log. It has a vertical asymptote. It takes all of the ordered pairs that are on the natural exponential, and it reverses the inputs and outputs. So 0, 1 becomes 1, 0. 1, 2.7 becomes 2.7, 1. And 2, 7.3-ish becomes 7.3-ish, 2. And that's the 12 parent functions that are very important for you to have down pat so that you can work with these functions in an Algebra 2 class, a college algebra class, and above, anything from Algebra 2 and above. They're basic facts, just like in elementary school with adding, subtracting, multiplying, and dividing. You need to know those facts. In high school, there are a couple of things that need to be quick in your recall, and that would be exponentials and parent functions. So the better you know these, the easier it will be to work with these functions throughout the course.